Hi, good morning. And so we're just going to look at something called quadratic factorisation. Some people refer to this as trinomials, but trinomial just means three terms. Quad, as in a quadrangle, a square. This is what we're dealing with. So I'm going to go fourth. So, like I'm saying here, we have multiplied out the contents of two brackets, and inside them, two things, two terms in each of the brackets. 2 times 2 is 4, so you end up with 4 things, but maybe things can interact, and we'll end up eventually with something like that there. So we've done it before, so you can go and check. And yet another one. You can multiply that out either the way I've shown you or your teacher at the school using the FOIL method. That's fine. That only works when there's only 2 things in the brackets. If there's 3 things in each of the brackets, it will not work. Okay, you'll end up with spaghetti bolognese. Okay, so we'll end up with that. So the aim of the game here is to reverse the situation. So here we go, we get 2 quadratic expressions here. And because there's 3 things involved, we will call them trinomials. So how do we decompose them into their linear factors? That's what it's called, linear, because each of the x's are actually x to the power 1. How do we get there? And that's the purpose of this wee lesson. Oh, right, before we go forward, these are all some very, very important things. Sign multiplication. Plus, plus, minus, minus, plus, minus, minus, plus. I should have actually said positive, positive, negative, negative, positive, negative, negative, positive. Because positive is actually different from plus, and negative is different from minus. But see, for our purposes, we can treat them the same. Up until a point. Right, so I'm just picking a number here, positive 14. And we're just going to, there's an infinite number of pairs of numbers that will give us positive 14. So we're just going to stick with nice numbers here. So I'm going to go for 4 selections here and see if you agree here. Usually you wouldn't, if it was 7 times 2, usually you wouldn't put a positive in front of them in your calculator, but I'm just wanting to emphasize that these 2 positives give me a positive 14. 2 negatives, negative 7, negative 2 gives me positive 14. Positive 14, positive 1 gives me positive 14. And negative 14, negative 1 gives me positive 14. That's what we're driving at here. We had to have similar signs in the brackets. So pay attention to that. We had to have similar signs there. Okay. Now, it doesn't matter if it's negative 6. Our target is a negative here. Which pairs will get as a negative? And again, I'm just going for 4 pairs here. To have to read them all out, positive 2, negative 3, negative 2, positive 3, positive 6, negative 1, negative 6, positive 1. Yes, I could have negative 12, negative positive a half, but we're staying with nice numbers here. later on you'll have to deal with numbers that ain't so nice. Well, maybe in your frame of mind, not mine. So they all work. Okay, so these are the kind of things that we are looking for here in this topic. And as we've said here, to get a negative, we needed different signs for the pairings. Okay, this might look a little bit bizarre, but just need to stick with it. I'm just going to stick with x squared. It could be y squared, it could be z squared, it could be a squared. But what we sometimes call it is we have the unitary coefficient. That means a number in front of x squared is 1. That's what we are going to be dealing with. It'll be 1x squared. Okay. So from now on, that's what we're dealing with. This will be a number, that'll be a number. And likewise, it could be like this. So these are the two situations, and sometimes they like to refer to these as cases. And like it says here, they're just going to be numbers. Okay. Right, so the first situation or case is when the n number, the constant is just a number on its own with no letters attached to it or multiplying it. Okay. So here, and it's a positive. That's what we're interested in here. So we're now going to split this trinomial quadratic expression. We're going to split this, well, as a quadratic trinomial expression actually. We're going to split it into two parts, and we're going to just put them into little brackets. So because it's, we start with x squared, initially what we can do is just put in x times x to give you x squared. Right, okay. That's fine. So the next thing we need to sort out here, using this method, there are other methods, but I'm just using the one method. Here, what I'm going to do again is I'm going to look at the n term, the constant term. Because that constant term, the number on its own, what that tells you is the signs of each to the right of each of these x's, they have to be the same, either two positives or two negatives. So we need something else to make up our mind. Are they both positive or are they both negative? This is where the middle term comes in. We know to the right of both the x's we're going to have the same sign, but it's the sign of the middle term that shall determine it, if they're both positive or both negative. Okay. If the sign of the middle term is positive, then in a bracket to the right of the x's, they will both be positive. So the plus VE and the little cloud there, that means positive. They will both be positive. Okay. On the other hand, if the sign of the middle term is negative, that's the middle term, okay? Middle term negative, then the signs to the right of the x's in the brackets will both be negative. So, like we're seeing here, so the sign at the end is positive. That's what I'm talking. This is a sign that the constant term, the number on its own, with no x's, no letters attached. This thing here, that's positive. The only scenario upon the factorisation, the decomposition, whatever you want to call it, has to be the following. X plus, or x minus, they are the only two possibilities, because you need a positive and positive to give you a positive, or a negative and a negative to give you a positive. They are the only two options. We don't speak about zero. Okay, let's go for something here. Let's go for an example. So we x squared plus 5x plus 6, and everything's positive here, so this will be a nice one. But I think we can sort it. What can we sort out right away? We know it's going to be x times x to give you your x times x to give you your x squared. We know that. Okay. Look at the end term. Okay, it's positive. Positive 6. So that means the signs to the right of the x's must be the same. They must be the same as the middle term. That is positive here. So signs to the right are both positive. Okay, so now we just need to do one little check here. And the checks are two numbers that multiply to give you the n number, and two numbers that add or subtract to give you 5, the middle term, regardless of signs. And we'll stick with nice numbers here. So it could be 1 times 6, could be 2 times 3. We'll stay away for 12 times 0.5 or 12 times a half. Okay, it's the top check for the constant term. That's the constant term. Number without no x pals. That's always multiply. Always multiply here. The second check relies on the constant term at the end. If it's a plus or if it's a minus, positive, negative, it tells you that you're adding to get the coefficient of the middle term, regardless of sign. So here, like we're saying here, this is two jobs here. It tells you about the signs in the brackets, and it tells you where to add or subtract on the second check. So we're adding here. Right, so two numbers that multiply to give you 6 and actually add to give you 5. There are only two possibilities here. Well, for us, there's only two possibilities. And I'm sure you've guessed them by now. 2 and 3, or 3 and 2, and 2 and 3, or 3 and 2. Right, okay. So now that we've established that the checks work, we just need to put them into the brackets after the plus signs. Because we've established our plus signs, the numbers are positive. And like I was saying there, I'm just re-emphasising, these are the only pair that will work. Put them in. Doesn't matter where the 2 or where the 3 goes, because both are going to be positive. So just put them in there. That's fine. And just like I've shown you there, I've switched the order. So just to think about 5 times 4 is 20, and 4 times 5 is 20. So the order does not matter here. So that's us, all done. And I've double underlined it because I'm happy with that. Okay. I'm just re-emphasising here that both of these are equivalent. Why don't you go and multiply them out? Because you're good at that, and see if you get the result from both of them, which should be x squared plus 5x plus 6. Yep, and it comes out like that. Okay. Let's see how we go. Can I speed it up? Everything's positive here, so everything will be. It'll be okay. Right, let's set up the brackets. Get the x's in. Because it's x times x is x squared. Let's look at the constant term at the end, the number without any x's or any letters. We're looking at the sign, it's positive, so it tells us the signs to the right of the x's must be both positive or both negative. Right, so we'll get the same signs here. They will be the same as the middle term. So they're both going to be positive again. Right, sorted. Just need a couple of numbers here for our check calculations. Two numbers that multiply to give you the constant term, and two numbers that multiply to give you the coefficient, the number in front of the middle term, okay, regardless of sign here. But again, we need to decide, are we adding or subtracting here? It's a sign of the n number again. It tells you if you're adding or subtracting. We're going to be adding here. Right, okay. So two numbers that multiply to give you 14 and sum up, add up to give you 9. I'm sure you've thought about it long and hard. What are they for you? 7 and 2, 2 and 7? I think so. There you go. And because both the signs are the same in the brackets, to the right of the x's, you can put them in any of the brackets. Okay. Let's pop them in there. And that's you done. That is us factorise the trinomial quadratic expression. Right, okay. Oh yeah, and we double underline it because we were so successful. Right, another one. Quicker this time. Yep, it's quadratic because it's squared. It's trinomial because there's 3 terms. Let's start factoring it. Let's get the 2 brackets in there. Let's x times x, because that's the variable we're using here. Letter, whatever you want to call it. Let's start thinking. N term is positive, the signs are the same. Okay, they've got to be the same. They've got to be the same as the middle term. That means they're both negative there. That's fine. Let's go and get the checks here. So the multiplication term is always in relation to the end number. Well, it doesn't always have to be the end, but it's a constant term. The number of the letters or variables is 12. But the bottom one here, we need two numbers that either add or subtract to give you 7. So here, yet again, that also depends on the end term. That's telling us we need to add two numbers. Here we go. So what are your two numbers? Initially, it's good to know your times tables. You don't have many selections, but I'm sure you've pinned them down. 3 times 4, 4 times 3, 3 add 4, 4 add 3. Yeah, we're pinning them down. Because the signs are the same in the brackets, it doesn't matter where we put them. Okay. Right. That's us done. Oh, we're going for another one. Quicker. Brackets, x's, signs, two numbers that multiply to give you 35, two numbers that add because the 35 is positive up in the front line. Okay. Do your times tables for the top check. Okay. Times tables for this one. Once you've sorted out that, then I'm sure you're pinned down. 5 times 7, 5 add 7. I think they work because up here these are identical really, so it doesn't matter where you put the 5 and 7. Pop them in. That's you done. Okay, all done. Didn't even have to underline it there because we're getting faster and faster because we're getting better and better. And you know what? I sometimes say this. The whole point of these little video recordings is so you can stop and rewind. That's up to you. Right. You know things always change, so let's make the change. Different scenario here. In all the previous ones, the number at the end was always positive, but this time it is negative. So this is going to put a different spin on things. So let's see how this plays out. The good thing about the sign being negative at the end, but once you set up your brackets with your x and your x, that's always a given. In order for you to get two things to multiply to give you a negative, one must be positive and one must be negative. That is a given. And it doesn't matter the order in which bracket you put them in. They must both be different. So again, we're going to go for the check calculations. So the top is always the same. It's always to multiply to give you the n number, regardless of sign. Sometimes you call that the magnitude, whatever. Doesn't matter. It's always just a bare naked number. Right. That's fine. But the thing is, see the bottom, it's either add or subtract. That's what we're saying here. So that there, even though it's telling you that the number is negative, it's telling you here that you're going to have to subtract. So this is the scenario we're going to go for here. So let's go through it a little bit at a time. Yep, there is a certain deviation from the first set because the last number is negative. Right, it's always your brackets, your x and x. Okay, it's positive and negative because to get that number at the end, it has to be a positive times a negative. Okay, that's fine. Doesn't matter. In the checks, I have to emphasize again, the method I'm using, these two numbers always appear positive. Okay, so just strip away these here. So it's 28 for the end term, it's always multiply, and here it's always add or subtract. That's the important part for this one. Or for both of them. Right. That's what I just said. Here, always positive. Downstairs, the end term was negative, so we interpret that as being a wee minus between the two check numbers on the bottom line. Right. So give us two numbers, multiply to give you 28, and subtract to give you 3, positive 3. Okay, you've done your times tables, you've done your little check calculations, and hopefully you've chosen 7 and 4 for both of them. It's fine. Previously, you could put those numbers in either bracket, but the thing is, in this one you'll get x plus, and in this one you'll get x minus, or whatever you want to call it, right? Won't go on about positives and pluses and minuses and negatives being different. Okay. But like I'm saying, these numbers definitely work. But this is the crucial part. Which is positive and which is negative? Please take note of this here. Using this system, we have 7 and 4 here. Let's say the bigger of the two numbers always takes the sign of the middle term. This is a middle term. Okay, it's not always middle term, but we put it in order of powers. We'll speak about that at another date. Okay. So that's a bigger number. 7. You're comparing 7 and 4. If the numbers were actually the same, we'd be using a different technique. That should be addressed at some other point. Right. So as you can see, we've highlighted the middle term with a 3. It's got a negative. So that bigger number takes a sign of that. So that's 7. It's going to go next to that wee minus sign, that wee line. Okay? And there's only one other option for the 4. There's only one space for the 4 to go. In there. So that's all it's done. Is that okay? Maybe not. Right, I'm going to just do a wee quick thing here. See, if you take plus 4, take away 7. What do you get if you put that into your calculator? I believe you'll get -3. So that's a little check there for you to do. +4, the second thing is telling you what to do, either add or subtract, and it gets you -3. So that can be your final check. Okay, let's go for that one. You can pause this wee video if you want to have a go at this yourself, especially if you're well in class, and especially if you're a new viewer to Tommy's YouTube channel. Right, let's crack it. Brackets, x's, let's think about the signs. The number at the end is negative, so we're going to have a positive and negative to the right of the x's. I always put it in that order, that's just my habit. There's my check. On the top, so always multiply to give you the end term regardless of sign. And downstairs, two things that add or subtract to give you 2. Again, the ends is a constant term because it's got a wee line in front of it, you got a negative or a subtract, it tells you downstairs we're going to be subtracting here. Okay. Right. So do your times tables again. 35, you don't know many numbers with 35 in your times table. Probably 7 stands out for you. So 7 times what to give you 35? And 7 or something take away 7. 7 take away something or something take away 7 to give you 2. 75, 75? I think so. Right, here we go. But because in the brackets, one's a positive, one's a negative. Okay, where do we allocate the signs here? And this is a game of spot the big number. So this is not infantile. This is to just point you in the right direction. I was going to say educate you, but that's what we're doing here. Right. Okay. Which is bigger? And this is very important. I put important things in what I call jaggies. That's a jaggy. Not a cloud, it's a jaggy. Right. So, the bigger number, always take the sign on the middle term. That's a bigger number. It takes the sign of the middle term. Middle term, there. Okay? So that 7 is forced to be positive here. So in the left-hand bracket, that's where it's going to go. Which forces the 5 to get into the only available seat. That's you done. All done. All done. And I think that's me all done. So hopefully that helped you. But in regards to this lesson, I'm just going to go back here. And I just want to point out here, just taking this example here. All the examples I'm looking at here, it's only when what we call we have just single x squared, or sometimes they call that the unitary coefficient. We don't have a number other than 1 multiplying x squared. So if for that there, you should consult, well, if you're in my class, my notes. And for us, it's on the unitary coefficient we're looking at, i.e. we want to deal with 1x squared. So we'll just take it to the end, so I can end this nicely for myself. Right, so I think that's me. So if this is to your taste and it helps you, good. Thank you. Bye bye. So 3:15 in the morning. Bye.